All right, so that video has to do with an exciting announcement that came out of the University of Alberta. Today, President Bill Flanagan was up on the main stage upstairs giving that announcement, and you may recognize some of the faces from that video because they've joined me on stage here to dive a little bit more into that announcement and what's happening at the University of Alberta around hydrogen. So before we get into the discussion, I'd like to turn it over to our panelists to introduce themselves. So Aminah, can we start with you?
Thank you. Welcome, everyone. My name is Aminah Fayek. I'm the Vice President, Research and Innovation at the University of Alberta. I'm also a faculty member in the Department of Civil and Environmental Engineering in the Construction Engineering and Management program. My research is very industry partnered, and I focus on the application of artificial intelligence to develop decision support systems to improve the productivity and performance of the construction industry. In my current role, I led the University of Alberta's first pan-institutional strategic plan on research and innovation, where we defined our areas of global excellence and areas of growth, and defined some goals, objectives, and actions so we can really maximize our impact and solve some of the world's grand challenges.
Awesome. And Amit?
Yeah, good afternoon, everyone. It's a pleasure to be here. I'm Amit Kumar. I'm a professor in mechanical engineering, also a Canada Research Chair in Assessment of Energy Systems. A lot of work that I do is focused on developing information for decision making, a lot of policy formulation, a lot of investment decision making. And I would be leading this center that we have just announced. Thank you.
Hello, everyone. I'm Hassan Dehghanpour. I'm a faculty member, the Department of Civil and Environmental Engineering. I'm also the co-director of the School of Petroleum Engineering. And my research is currently mainly focused on underground hydrogen storage.
All right, thanks for those introductions. And before we dive in, I will just mention that we are going to do our best to get to some audience questions at the end of the discussion. So if you're watching online, if you're in the audience, keep those questions in mind, and we'll do our best to get to them at the end. But Aminah, let's start with you. Can you talk broadly about how the University of Alberta is positioned to respond to society's current and future energy needs?
Yes, I'm happy to. As I mentioned in our strategic plan, energy and environment is one of our areas of global excellence. We're also in the top 50 universities globally for energy and climate-related research, and the top 10 for energy systems research. We have two very significant programs focused on energy. One is Future Energy Systems, and one is the recently launched Canadian Net Zero Energy Solutions Program. Both of these are really responding to Alberta, Canada's, and the world's need for our transition to sustainable energy sources. We work very closely with industry and community partners to develop technologies and solutions tailored to their specific contexts. And we also know that in Canada we have some very remote and northern communities, so we're very focused as well on developing solutions that work in those contexts. Future Energy Systems is a federally funded program. It was funded through $75 million from the Canada First Research Excellence Fund. And this is a long-term initiative. We're now in our final years, and we've established what's called the Accelerator Fund to really partner with industry and make sure that the technologies we've developed are taken into the implementation phase with our partners. Most recently, we established CANSES, our Canadian Net Zero Energy Solutions Program, and this was really in response to significant demand from industry. Through this program, we're taking some of the work we're doing from lab scale to pilot scale to true market readiness with the help of our industry partners. And we're working in 5 very complementary areas: carbon capture, utilization, and storage; hydrogen, which my colleagues here are going to talk about in more detail; resilient grids for sustainable energy and zero-emission vehicles; land and water reclamation; and critical minerals. So each of these areas is standalone with its own industry partners, but many are very adjacent and, as we know, are very complementary to each other. We've raised right now for CANSES over $113 million in commitments from industry, from government, and from communities, and we're looking to expand that through additional partnerships. As you saw this morning, we're very proud to announce the launch of our Centre for Hydrogen Innovation, Workforce Development and Outreach. And this is really consistent with the hydrogen theme that we're focused on. What's unique about this initiative is it really bridges the gap between academia and industry by making sure that what we're doing is co-developed and partnered with industry. And I know that my colleagues will be talking further about that. But in addition to the technology development side, this center unites over 60 researchers from multiple disciplines across campus. So looking at everything from the technology to the policy piece to the social implications. And it's also very focused on workforce development and training. And that includes work-integrated learning and skills training, which is really critical if we're going to solve the energy challenges. So we do provide students with that hands-on experience, and many of these students go on to become employed in our industry partner organizations to really ensure that we take this to the next level.
That's excellent, and it's really great to hear about the funding that's coming into these projects. I think that was something that President Flanagan highlighted too up on the main stage about the need to fund these critical research projects, so that's excellent. Can you, and the other thing I want to touch on is around collaboration, because that's also a word I think we keep hearing upstairs and on the stage here. Can you talk a little bit more about how the University of Alberta partners either with the private sector, with government, or other entities?
Yeah, I'd be happy to. That's very core to what we do, and collaboration and partnership. We cannot do this, any one group, on its own. So it's really important that we come together and maximize that collaboration. The way we do this at the University of Alberta is we have a long-standing history in developing research centers that are very industry-focused. And by that, what I mean is that industry comes to the table with not only cash, which is really important, and we take that cash from industry and we leverage it multiple times over with federal funding initiatives as well as provincial matching. So for example, we use the MyTax program, which some of you may know about, that allows us to have student interns that actually work with industry to deliver solutions that meet their needs, and then they often go on and become employed by industry. We also have the Natural Sciences and Engineering Research Council. They have a number of partnership programs that take an industry dollar and match it up to 2 times. So we really leverage that industry cash. The other thing we do, though, is we create, through these centers, we have advisory boards that are made up of all the industry partners and the community and government partners. They're the ones who help us to co-develop the projects. And in doing so, we actually work with them very closely. We have our own students and our faculty at these organizations solving problems that are relevant to their needs. The other thing, though, we're able to do as a university is bring together competitors who may not otherwise work together. And in doing so, we're delivering innovation not only to an individual organization, but to the industry as a whole. And that's a real advantage by being able to bring these industry centers, industry-focused centers together. So as you know, we just launched the Hydrogen Center, and I know Amit will speak more about that. The other one that we recently launched is the Center for Applied Research in Defense and Dual-Use Technologies. We called that CARD Tech. And the University of Alberta is also a NATO-DANA test center, and so we're working very closely with industry and with government to ensure that we meet Canada's national security priorities, and that includes protecting the Arctic and northern regions as well. So those are just some of the ways that we partner in this model, but there's many other things that I'm sure my colleagues will address.
Yeah, that's great, Aminah. Thanks for walking us through that, and I think the defense one is particularly interesting right now, given the geopolitical kind of scenario we're in, so super important to highlight that, and just the incredible industry partnerships and innovation that are coming out of the University of Alberta truly is a gem for the Edmonton region. Amit, I'm going to turn it over to you to dive a little bit more into this new center that's developed. Can you talk to us a little bit about the vision for the center?
Yeah, happy to. You know, I want to go back a little bit in terms of 3 years ago when the government of Alberta developed the Alberta Hydrogen Roadmap. Since then, we have seen a lot of activity in Alberta and growing interest in Alberta. And this has also happened in academia too, with, as Aminah talked about, large critical mass of researchers coming in. And now we have over 60 researchers who have interest and who are working on hydrogen. So this is the time when we realize that it makes sense to have a much larger push, the same as we had, for example, if you go back decades in terms of the oil sands industry. How did we change the industry itself and develop this new industry? And this is where we are in terms of hydrogen. So our vision for the Hydrogen Center is to develop and advance technologies to basically help in policy development, help in workforce development, which is critical for taking the hydrogen industry to the next level. And that's our long-term vision for the center. If you think about the hydrogen value chain itself, so there are critical value chain in terms of producing hydrogen, transporting hydrogen, storing hydrogen, and utilizing hydrogen. So our center basically covers the whole value chain. We have researchers who are working on hydrogen production. You name the resource, and we have researchers who are working on this, both renewable, non-renewable sources, blue hydrogen, different technologies for blue hydrogen, steam methane reforming with carbon capture and storage, autothermal reforming with carbon capture and storage, methane pyrolysis. In terms of renewable hydrogen, we have people working on solar-based hydrogen. And so a lot of these technologies which we use to produce hydrogen today, there is cutting-edge research where we are working on, and we look forward to developing new technology and collaborating with the industrial partners to further develop and enhance their technologies. We also have pillars where we are looking at the hydrogen transportation. Hydrogen transportation, I mean, we all know that there are different modes of transporting hydrogen. Pipelines, trucks, rails, barges. There are challenges in terms of how do you get into a form to transport? How do you develop those materials where you use the pipeline materials specifically for hydrogen? And so there are researchers who are working on these kinds of, and trying to answer these kinds of research questions. In terms of storage, and I know Hassan will talk more about it, but we are working on both physical storage and chemical storage. And Hassan's work is one of the examples. But he'll talk about physical storage. In terms of the chemical storage, I'll also mention that a lot of talk that we look at ammonia, methanol, liquid organic hydrogen carriers. So there are researchers who are working on solving the challenges for these types of chemical carriers which could be used on large scale. And on the utilization piece, we have people who are working on developing these engines where we can fire hydrogen. And these are already kind of, at pilot and demonstration scale. Lots of work and a lot of, I would say decades of work on fuel cells and different levels of different types of fuel cells. So the whole chain, the 4 vertical pillars that we talk about in terms of production, transportation, storage, and utilization, there are lots of researchers who are working on this. We have gone a little bit ahead and thought about in terms of the other enablers which is needed to move this hydrogen economy forward. And so we have 4 horizontal pillars, and where we talk about hydrogen value chain enablers, which are not particular to one pillar or just for production or for transportation or for storage or utilization. These are valuable for across all of these hydrogen value chain. For example, materials, catalyst development, material development, optimization, sensor development. These are different aspects that the researchers are working on the horizontal pillar. We also have a lot of capacity in terms of value chain modeling. And this is close to my heart because I do this, but there are a lot of researchers who are working on developing these information for policy development and investment decision making. We also have 2 pillars which are critical for moving the hydrogen economy forward. And this is workforce development, where we talk about developing a lot of these short courses, a lot of certificate programs, degree programs also in hydrogen. And then, over the last 3 years, and if you talk to a lot of different stakeholders, one of the things which comes out is that we do need to educate public in terms of what hydrogen is, how safe it is. Is it okay to bring it to our home? Is it okay for the pipeline to go from our near to our communities? So these questions, education to the public and outreach is again another critical aspect for the hydrogen economy. So that's another key challenge that we are trying to work on. And then I'll end with saying that we have developed this structure in such a way that we are open to partnership.
we have developed a structure where different stakeholders, industry, government, community can come in and help us shape the research, help us identify the challenges, and work with us in solving those challenges. And that's kind of what our vision and the overall structure for the center is.
It's great. It's a really holistic approach, it sounds like, and I imagine a lot of opportunities for cross-collaboration and shared learning, so I'm excited to see what comes out of the center. I understand that the center also aligns really well with the university's historical roles in policy development, think tank engagement, and support for the hydrogen ecosystem in Alberta and the Edmonton region. Could you speak to some of the work the university has done in these areas, including the work that you're doing as well, Amit?
Yeah, so if you think about, from technology development to decision making and policy development. So technology developer, for example, Hassan, he develops technology on energy storage. We have John, we know he develops technology on hydrogen production. But the information from the technology developer needs to travel and needs to be transformed in such a way that it could be used for policy development and decision making. For example, how much does the technology or a certain technology for producing hydrogen costs? What scale do we build it? How do we implement it into the whole hydrogen value chain? These are critical questions. So these needs to be transformed. So a lot of work that we do and a lot of work that we have done in the past is try to answer these questions for the government, for the industry. And one of the examples that I can give is the Alberta Hydrogen Roadmap. We did a lot of modeling, more than 300 different scenarios in terms of what technology for production of hydrogen, how do we transport hydrogen, what are the opportunities for Alberta-based hydrogen globally, not only in Alberta, not only in Canada, not only in North America, but globally. What are our bigger markets? How much does it cost to deliver hydrogen in, for example, Asia-Pacific countries like Japan and Korea? So a lot of these questions that we have answered and we have tried to answer, which helps in developing these policy formulation and decision making.
That's great. I do want to ask you though, Amit, because you've been working in hydrogen for, it seems like quite a long time. You're one of the, I think, early researchers in this area. What do you think is going to be different with the center? Like, what are you most excited about coming out of this announcement?
Yeah, and I think one of the biggest thing that this has done is this has brought the number of different researchers under the same umbrella. Over the last 3 years, we have a lot of interest, and a lot of people have now started the program and developed research program in hydrogen space. And then now we see that you have expertise in each of these different aspects of hydrogen value chain. What I expect and I hope that this center helps us in bringing a lot of these researchers, not only at the university, but across the globe, but also the community partners and different stakeholders under this umbrella where we try to solve some of these challenges. See, we have been working for the last 3-4 years in Alberta and focused on hydrogen. We are getting to a point where now we kind of realize what are some of the critical challenges. And these centers now, we think that we could try to address these challenges together. And then help, again, the vision that we have for Alberta in terms of making it a global leader.
That's great. It's exciting. Hassan, I'm going to turn the conversation over to you now because your work, as I understand it, relates directly to one of the pillars that Amit has been talking about. Can you talk about the specific research project that you're involved in?
So we all know that Alberta is the hub of energy production in Canada and maybe even in North America. So 3 years ago, we came up with the vision that we can also be a hub of energy storage. And we went around and looked into past activities of energy storage in Alberta. We realized that since 1960, for the last 60 years, we have been actually storing natural gas, hydrocarbon, or other materials in salt caverns, depleted reservoir aquifers in Alberta. There are around, actually more than 100 salt caverns up and running in Fort Saskatchewan. And most of us in oil and gas at U of A we didn't even know that we have that many salt caverns. And then we started thinking about energy storage in general for the energy transition and hydrogen storage in particular. We found that one of the key technologies that can be adopted for larger scale hydrogen storage is salt caverns. And we already have the technology around us. We have the massive underground resources in Alberta, which one of them is the Lotsberg salt formation. We have around 500,000 square kilometer of salt formation laterally in Alberta, plus for Saskatchewan, and if you look at multiple layers, is more than 1 million square kilometer of salt formation. This is massive. So that plus the domestic technology that we have for developing and operating these salt caverns, plus the natural gas production facilities that we have, and carbon sequestration. When we put all of that together, we have a massive infrastructure, expertise and experience to become actually the hub of energy storage. So we came up with this vision, and I had very exciting last 3 years at U of A, because I've been working with multiple stakeholders, federal government, provincial government, funding agencies, as well as exciting industry partners from the operating oil and gas companies, service companies, utility companies. All together, we form a consortium for subsurface energy storage. So we have had, every year we have had specific workshops at U of A, one day before this hydrogen convention. So last year was a great success. This year, yesterday was even more successful. We had more than 70 participants from around the world, mainly from Canada, provinces outside Alberta, and it was very well attended. So everyone is looking in what Alberta is doing in energy storage in general. So we're not specifically only focused on hydrogen storage, but also looking into the possibilities of compressed air storage and even ammonia storage. So one of the presentations yesterday was around the possibilities of safely storing ammonia potentially in salt caverns. I've been very lucky to be working with this group of stakeholders, and we were able to secure around $5 million in the last 3 years for this R&D activities.
That's excellent. And I understand that you've actually had some success stories come out of your lab. Can you talk about a specific technology maybe that was developed in your lab that is now actually being used and deployed in industry?
Sure. So there were some discussions today at the strategic meeting about time to market. I have been very excited to see that the time to market for subsurface storage has been very quickly here. So we got the buy-in for actual field trials in a year. So not only in Alberta, we got also investors from Newfoundland to store hydrogen compressed air to convert the hydrogen from wind, solar in Newfoundland. Specifically was proposed by World Energy. And so there were some investments, and they drilled 3 well bores in Newfoundland. They found a domal salt. So they signed a contract with the University of Alberta that was matched by NSERC, MITAX, NRCan, Alberta Innovates. And so we received the core samples and the data from Newfoundland. And currently we are looking into the possibility of developing a salt cavern, domal salt caverns in Newfoundland. In Fort Saskatchewan, similarly, we got involvement of Keyera. They drilled a new well bore, and they have shared the fresh core samples from Fort Saskatchewan Lotsberg formation to investigate the possibility of developing a hydrogen cavern in their new facilities potentially in future. And we all know that ATCO has already developed mini caverns for hydrogen storage. So that's for the field part. At U of A, we developed a new dedicated hydrogen laboratory for basically bringing the field to the lab first. So our strategy is to first bring the field to the lab, which means simulate physically in laboratory the rock fluid interactions, which means in this case hydrogen, rock, and brine interactions at laboratory under field condition, which means the pressure, temperature, and fluid composition, to see what happens when high-pressure hydrogen interacts with brine and rock minerals. And we have done it very successfully. Some of it was shown in the video, and there was a lab tour yesterday at U of A, which we showcase some of these technologies. So that's for the lab part, and for the modeling part, all the lab data should be then go from the lab back to the field. And for that part, we have developed a software that we are using the lab data for upscaling our findings for field scale prediction. For example, if a particular rock samples, we see a certain diffusion rate of hydrogen or a certain reactions that results in a byproducts, you would like to know for a full scale hydrogen cavern under a certain period of time, how much hydrogen loss we will have, how much hydrogen contamination with other byproducts we will have, and what are the potential risks. So all of these data combined will be translated into eventually guidelines for developing optimum salt caverns for hydrogen storage, which means the placement, the shape, the design, and operational parameters. And lastly, they have to go into the codes and the standards. Currently, we have CSA Z341 for hydrocarbon storage in subsurface formations. There is an amendment for that one for hydrogen storage that requires a lot of field and lab data, and we are part of that. Thank you.
That's great. And what I really love about this conversation is I feel like we've really gone from like the overall vision of the university around the energy transition and the future of energy down all the way to the really tangible examples where this technology is being deployed. So it really is, see the full spectrum, and it makes it really tangible for folks. We've got a couple minutes left, so I do want to check with our audience, either in person or online, if there's any questions from the audience that they have for our panelists.
I was wondering if you could give some examples of current industry partners you're working with on projects right now within the realm of hydrogen.
So our partners from the industry are currently from the operating companies are Kiera, ATCO, and Vortec Energy. And this is growing, but we're currently signing new agreements. And from the service part, Sangel for cementing of hydrogen wellbores, and cavern development companies such as Subterra Engineering and Remedy Energy Services.
Yeah, and I imagine from what I heard even from President Flanagan's announcement, part of the announcement of this center, I think, is a call to action to industry to establish more of these partnerships. And I can see the panelists nodding, so I'm glad I got that right. Is there anybody else that has questions? Okay, well, if there's no more questions, I think we'll end just by saying thank you again to our panelists for being here. Aminah, Amit, and Hassan, this was a great conversation, and we really appreciate you taking the time to share more about the vision and what's happening with the center.